Hello there Year 9, this is Mrs Cowlin with your third lesson for the topic of transport across membranes, and today's lesson is all about surface area, volume and calculating ratios. You are going to need a calculator for this lesson. You can use a phone if you're at home, but you will need a calculator when you're at school, so if you've got one it's good practice to use it now. There are 4 objectives. We're going to revise calculators area, surface area and volume, and learn how to calculate surface area to volume ratio. Now you might wonder, why do we need to do this? This looks like maths and it's science. The reason why is we already know from our second lesson on diffusion that surface area is important, and that a larger surface area increases the rate of diffusion. So we need to know how to calculate that surface area, and we need to be able to compare them after we've calculated them. So first of all, very quick reminder, you should already know these formulae from maths, I believe. So the 2D shape formulas, these are flat shapes. A triangle, the formula is half of the base multiplied by the height. So you find the base, find the height, multiply them together, and you halve it. For a square, you'll have the width multiplied by the height. They'll both be the same. For a rectangle, you'll multiply width and height. They won't be the same. Both of these being areas where you've got a unit multiplied by the same type of unit will give you a squared unit answer. It is very important to remember to check that the units are the same. You can't have 1 in centimetres, 1 in metres. That won't work. You would need to convert between them so that they're both the same units before you begin. Now, while you're doing this video, there's going to be quite a lot of diagrams and calculations. You will be able to stop the recording to copy down what you need to copy down. If you get confused, you can rewind to check. Now, if you've got a complicated shape, such as this one, they might give you something like this. You've got 2 different parts of a field, 2 different sets of dimensions. You're going to need to organise the information before you start. So you've got the height here, 60 centimetres. That's nice and easy, we can see that. But the width has been split into 2 parts. You've got a piece that's 110, piece that's 70. You need to add those 2 together first to find the total width, and then you can multiply the total width by the height and get the answer. That should be quite straightforward. I've chosen quite easy numbers that will actually match in with your multiplication knowledge, hopefully. Now when you get to surface area, it starts to get a little bit more complicated because you've got to visualise the shape in 3D. We've got a cube here. We can only see 3 faces, but if you think to a playing dice, which I'm sure we've all been playing lots of board games recently, you'll know they have 6 sides. You know that because the biggest number is 6, the smallest is a 1. And on a cube, all the faces are squares, which means that both sides have the same length. And you can find the area of one side, one face, by multiplying the lengths of the 2 sides. And then to find the total area for the cube, you have to multiply the area of one face by 6 because there are 6 faces. So the example here is a cube which has sides of 1 and 1, so you have 1 times 1 to give 1 square centimetre. You've got 6 lots of 1 centimetres for your answer, so 6 lots of 1 centimetre squared will be 6 square centimetres. When you have a cuboid, it gets more complicated, and you might need to do yourself quite a lot of drawing, because here you will have 3 different dimensions. Yeah, so on this one we've got a width of 3, a depth of 2, a height of 6. So that means we have got 2 faces at the end, which are the same size. We have got 2 sides at the front and the back that are the same size, and we've got 2 bits on the edges which are the same. So the smaller square ones are 3 by 2, which will give us 6 square centimetres, and there are 2 of those. There are 2 where you've got a 6 centimetre side and a 2 centimetre side to multiply together, and that will give you, that one is 12, and there's the second one like that. You'll have 2 where you've got 3 centimetre width and a 6 centimetre height to multiply, 3 times 6 to give you 18, and for each of these calculations you've got 2 lots of, so you've got 2 lots of 6, 2 lots of 12, 2 lots of 18. Work out the multiplying of the numbers first, then add the parts, and here that will give you 72 square centimetres. The way I did it was adding 12 and 24 together to get 36, and then you've got double 36 to give you 72. When you come to volume, this is different again, because area is a flat measurement. It's the measurement of a face, and even when it's a surface area, you just multiply it by the number of faces. When you're going to volume, it's actually how much space is inside the shape. And this will be a cubic measure because you've got 3 dimensions you have to multiply. You have to have length and width and height to multiply. There'll be identical numbers for a cube. There'll be different numbers for a cuboid. The answer would be in centimetres cubed if the measurements are centimetres, metres cubed if they're metres. And if you had a cube with size of 3 centimetres, the volume would be 3 times 3 times 3 again, which is 27, and the answer would be in centimetres cubed. I think this is quite straightforward. Obviously you will be pausing as you go. When you get to a cuboid, it gets a little bit tricky, but not as tricky as a surface area. I think the volume of your cuboid is actually easier because all you've got to do is make sure you've got the 3 different lengths, the width, the depth and the height, and multiply them together. And 3 times 2 is 6, and 6 times 6 is 36. Remember that you've got 1, 2, 3 measurements, so you'll have a 3 as your superscript or your indice, whichever one you want to call it. Now, in order to compare the relative size of an area and a volume, we find a ratio. So that little cube we had at the beginning, 1 by 1 by 1, the face was 1 square centimetres, so surface was 6 square centimetres. The volume was 1, so without any units in, with a colon, not a decimal point because this is not a whole number, you're comparing, it's a ratio, so you need a colon. You have 6 for square centimetres and you have 1 for volume. So the ratio is 6 to 1 for area to volume. If you want a challenge, there is the opportunity either now or at the end to actually work out the surface area to volume ratio for the cuboid. Remember, you should be able to simplify it. Example number 2 here, if you had a cube that was 3 by 3 by 3, the face would be 9. 6 lots of 9 will give you 54 centimetres squared for surface area. Whoops, didn't mean to highlight. That's come down here, 54. Your volume would be 3 times 3 times 3, which would be 27, which is here. Now, luckily, I quite like spotting patterns. 54 to 27 would be acceptable. Whoops, sorry, I obliterated that when I moved it earlier. But if you're good at spotting these things, you'll realise that 27 is half of 54. So you can divide them both by 27, you'll get a volume of 1 and a surface area of 2. When you get it to simpler numbers like this, that makes it much easier to actually compare the surface area to volume ratios for different shapes. Now, I think that should give you most of what you need. The good news is there is a word worksheet to support this lesson with examples to practice on. You'll be able to download it. You'll have to click the button at the top that says enable editing. Then you can put your answers in there, save your work, and then you can upload it onto Teams to get feedback from your teacher. And I've put the challenge question from earlier in the PowerPoint on here as well, so you've got that. Remember, you will need a calculator for this. You will need to know the formula for the triangle and the formula for the square, for the area, and from those you can work out everything else you need to know. Thank you very much for your time. I hope you enjoy this challenge.